some of the things you're going to learn right now, today like this, is cool. You don't have any assignments, isn't it? You don't have any homework. You don't have any assignment, nothing on Monday. You don't even know some of your colleagues right now. So life is cool, I'm telling you. But from week 6, week 6, you would have known friends, you would have known family members here, you would have coordinated with some people. You get assignment from unsupervised, assignment from statistics for business, assignment from data wrangling, assignment from strategic analytics. Assignment. Then your head is starting, you got assignment. And at that stage, you will say, Eddie life, no. But I don't worry. Forewarned is forearmed. So now that I've told you, be prepared that you will learn immediately. You will not wait for things to pile up. Guys, I beg you, don't do it. Don't do it. People are going to be teaching you 11 weeks, 13 weeks, 11 weeks, 13 weeks, 11 weeks, 13 weeks. Okay? Decide that you're going to learn today. Everything you are taught this week, use the rest of the midweek to learn it. So that by the time we come next week, you are already consolidated mentally. Your mental gymnastics has arisen to the highest apogee. Before we go to the next one, elevate your mental consciousness. If you want, I will elevate it for you. If you will not use your write this down. Write this down. RAS. Write it down. RAS. Write it down. Have a book. Those of you who don't have a book, I can see somebody is using a paper. Now, paper, please have a book. Have a book and write everything down for all your subjects. RAS is a reticular activating system. Write it down. That's the full name. Reticular activating system. You can Google it later. Guys, your brain works in a certain way. You see, the reason why I normally do this on my first day is because I want you to know how your brain works. I did medicinal toxicology. And your brain functions in such a way that the moment you begin to expect something, that something appears. I want you to write that down because that's the meaning. Because the information symmetry between your thalamus and your hypothalamus, that gap where your medulla oblongata unleashes information, it only manifests because you have called it into your memory. And so each time you want a particular subject to be easy, you can make it easy for you. And the only way you can make all the subjects, you are doing 5 subjects or 6 subjects. Which one? Is it 5 or 6? 6.
6.
So you are doing 6 subjects. And I'm going to use this principle to help you to do well in all of them. Because sometimes somebody say that as for statistics for business, I don't like it at all. Or even the strategy is okay, but this one, no. It is the way you have programmed your subconscious mind. So this is what I want you to do. I want you to have a sheet of paper. Okay? By the way, everything I'm saying is in a book called As a Man Thinkers. Have you heard of that? As a Man Thinkers. So He Is, by James Allen. Write it down. I told you I'll be giving you 5 books every day. This is one. As a Man Thinkers. So He Is. It's by James Allen. That's a book. That's a book. So get that. It's a very tiny book, but it's so powerful. So now let me go back to the reticular activating system. Have you ever had that zeal that you want to buy a particular car? That's a car you want to buy. Let's say you want to buy a V12 Land Cruiser. The day the idea came into your head that you want to buy a V12 Land Cruiser, all of a sudden on the road, you start seeing V12 Land Cruisers. Have you observed that? And then you start saying that, the car that I now want to buy, all of a sudden people are using the car. It's not that all of a sudden people are using the car because you beckoned it. You called for it. You activated your reticular system. And you called for it, and now you are seeing it more. And you see more of that task that for that particular week, you see it more because your mind has been activated as a man thinkers. So the same way, I teach a course in MPhil. It's known as multivariate data analysis. One time, one of the guys got up in the class and said, "Doc, as for this course, I know I'm going to fail." I said, "Don't ever say that." Then another friend of him got up. "Don't say what?" "Doc, don't say what? My mother failed. My father doesn't like this course. Even my brothers, they don't like this kind of mathematical course. I know I'm going to fail." And truly, truly, they failed. When I released the results, they came to my office and told me, "Didn't we tell you we were going to fail?" The human mind is the most unexplored continent in the universe. Write it down. The human mind is the most unexplored continent in the universe. You attract what you think about most of the time. You attract, and what you think about also expand. Guys, yesterday, you had a lot of thoughts. 96% of those thoughts were negative. Only 4% were positive. And so every time your brain is negativity, you can see it in the news. They always broadcast negative news, not positive news. Today, people are going to have wedding. Go and check how many news items will start broadcasting wedding. They won't. But when there's an accident on the road, they do that. So negativity is always coming. And that manifests itself in your subconscious mind. And so you see the cause. Hey, this cause is not easy. You keep talking about it. Tell it this cause, is when you do that, you magnify the problem. The negativity increases. You call for it. And so your reticular activating system will realize that you don't like the thing at all, and it will make you not like it more, and you don't like it more. And what happens? You program that into your subconscious mind. You begin to act in the direction of your most dominant thoughts. You begin to attract what you think about. And eventually, because you don't like it, you don't take action. And because you don't take action, you actually gradually manifest yourself into making the thing unlikable. Then what do? You now don't do well in the thing. And then you say that, I told you. So you reinforce your belief even more that you are not good in the thing. When in fact, that same negativity could be turned into positivity, and you can do that. So here's what I want you to do. Take every subject you are doing. Write the subject, statistics for business analytics. Unsupervised learning. Write A, statistics for business analytics. A, unsupervised learning. A, data wrangling. A, what are the other ones? Harry, what are some of the other ones?
Financial management.
Financial management. Then you write A. What else?
Database management.
Database management. You write A. What else?
Programming for analytics.
Programming for analytics. Ohono. You write A. And once you are done, sorry?
Data wrangling.
Data wrangling. You also write A. Then, when you have all these A, you put it in front of your fridge. You do the same thing. Paste it in front of your bed before you sleep. Okay, you take this one, you put it in front of your door before you leave the house, and put it in front of your door when you are entering the house. And paste it where you watch TV. Paste it on the right side. Let somebody enter the house and say, "Are you mad?" Guys, I did it. We had a 3.97 GPA in mathematics and economics. The reason is because we understood the power of your aid. We understood the power of your subconscious mind. The subconscious mind does not take anything for a joke. If you think negative, you see more negative. If you think positive, you see more positive. Once you have written the A down and your eye sees it, the eye is the pathway through which the mind and the body actually manifest. Once your eye sees it, your brain, and all you need is 21 days. You need to read a book called The 21-Day Cycle of the Human Mind. And once you begin to see the A, in your subconscious, without even you knowing, you feel you already have A. your body will elevate the molecular muscles. Okay? You will elevate molecules at the subatomic particles of your mind. You will elevate those molecules, and the molecules will coalesce to create cells. Write this out. Every cell in your body is eavesdropping on your internal dialogue. Write it down. Every cell in your body is eavesdropping on your internal dialogue. It's not the external dialogue. It's not even what I'm telling you now that matters. You know what matters? What matters is what you are telling yourself based on what I'm telling you now. You know, right now, as I'm saying, somebody is sitting there and saying, oh, Master, teach that thing and stop talking. You know, we are here for unsupervised learning and I'm talking about every cell in your body is eavesdropping on your internal. That statement you just told yourself, that is where the issue is. That internal dialogue. I can tell you that you are beautiful, but if you don't think you are beautiful, it's useless. You will act as though you are not beautiful because you think you are not beautiful. It's not me thinking that you are beautiful. Are you with me, guys? Are you with me? Give me a 1 if you are with me. Give me a 1. Give me. I need to feel you. I'm an energetic, interactive teacher. I don't just teach mathematical.
Yeah, here, Prof.
I want you to feel me, my energy, and send everybody in your house away. Anybody who is disturbing you, send the person. I need you to be with me the next few minutes. I want you to elevate your mental gymnastics to play because it's very important for you to be able to get this right from day one because you have 11 to 13 weeks to come. Every cell in your body is eavesdropping on your internal dialogue. So once you have written A all over, all you need is to continue to look at this every day for 21 days. Guys, let me tell you something, okay? That 21-day cycle of the human mind took me time to understand it. And by the time I finished it, I had 6 A's first semester, 6 A's second semester, level 200. 6 A's first semester, 6 A's second semester, level 300. 6 A's first semester, 6 A's second semester. I got 39 A's out of 40 A's in the entire program. When I did my master's, the same thing. I applied that principle. I taught the entire class. I had 7 A's. I applied my same thing in my second master's, the same thing. My first PhD, the same thing. And it went on and on like that. I am giving you a principle that will help you not only in academic work, but in even life. The same thing. The same thing. If you are in a marriage and you think that marriage is negative, you're always seeing that marriage even as negative. You will not see anything positive. The negativity expands. It expands. And the next thing you want to do is to back out of a marriage. But that same situation, somebody is going through that same thing. Write this down. Everything you are struggling in, someone is winning in. Write it down. Yeah. Everything you are struggling in, someone is winning in that thing. So the problem is not the thing. The problem is your operating system. This course and all the other courses, some will get A. I promise you on that. Some will get A. 2 of us.
True, very true.
But do you also agree with me that some will get F?
Yes, I agree with you.
Now, I'm not saying that you or Hina will get F, but what I am saying is that some, you can decide to put yourself in the A group or the F group. But do not underestimate the fact that the way you think is the way they think. Because once you are thinking positive that you get A, look, they are thinking negative. To them, they will not. Like, you know what some people do from the beginning? This course, the way it is, like statistics for business analytics. They see that it's all probability and all that. Hey, me, I just want C to pass. So me, I don't even want to. I want some C to just pass. You see the way he has begun to downgrade himself. He does not see himself there. And that is the beginning of not participating in your own rescue. So put that paper there and tell yourself you're going to get A, you will get A. As a man thinkers, so because right now you are standing on your acre of diamonds. Right now, all of you are standing on your acre of diamonds. So many people apply for the course. So many people apply. You are the creme de la creme. Okay? You are the champion of champions. You are the Pele Chinkafa Nawele Buburubush. And so you are the ones who are the beacon of hope for the entire business school when it comes to analytics. The entire country, you are the ones. And so chest out, holding out and tell yourself, I will break every module, every course before they break me. I will punish the course before the course punish me. I will disintegrate the course into pieces. Be so positive that negative people don't want to be your friends. Write it down. Be so positive that negative people don't want to be your friends. You are the average of the 5 people you're associated with. And look for the people that are concentrated in the courses. These are going to be your friends. If there are some who are your friends, tell them, please, when it comes to the course, you are not my friend, because they are not going to help you to move on. And befriend those that are so committed to this, because just the next 1 year and you are done. And that is the spirit that you want to have. I've given you 3 books, but I'll say 2. Another book I want you to keep in mind in this your journey, maybe even in your life journey, is a book called The Alchemist. The Alchemist by Paulo Coelho. Whatever you are looking for is already inside you. Alchemist, you know, chemist, just bring AL in front of it. Alchemist by Paulo Coelho. Somebody should put it in the group page, the WhatsApp group page. The WhatsApp group page is your classroom. Every Monday, every Tuesday, every Wednesday, those who are greeting and inspiring us, they are the ones I'm going to be giving marks to. With your partner, it's up to you. Okay? But I want it to be so engaging. You got to elevate your mental consciousness, because you are in an environment you cannot slow down. This is going to help you in your job. It's going to help you in your business. It's going to help you in your other areas of life. And that is what I want to institute around. Okay?
Doc, please, you didn't mention the author of the 21-day cycle of the human mind.
Go and find the author. Go and find the author. Life does not reward you. Write this down. Life does not reward you according to your wish. Life rewards you according to the quality of your knowledge. Life does not reward you according to your wish. Life rewards you according to the quality of your knowledge. Hosea 4 says, lack of knowledge, my people what? That's what I saw. Hosea 4 says, lack of knowledge, my people
perish.
So perish. Good, thank you. So that question, guys, fools hate knowledge. Ecclesiastes chapter 2, verse 7 and 22. Okay, fools hate knowledge. Ecclesiastes 2, 7 and 22. Fools hate knowledge. So watch this. You've got to be hungry for knowledge. For this thing we are doing, and not only this thing, even in statistics, in data wrangling, in financial management, database, all of them. Be hungry. Write it down. Be hungry for knowledge. Be hungry for knowledge. The same way you like food. The same way you like food. You like food. You like food. You see, you can be hungry for food. You can be thirsty for water. This time I want you to be hungry for knowledge. Because normally we are not usually hungry for knowledge. When there's exams, that's when you want to start going and learn. No. Be hungry. Every day you get thirsty for water. You got to be hungry for knowledge. Go into your room today when we are done. Go into your room. Change your room. You see my back? This is not my office. So this is my home. Okay? So go into your room. Design your room. Make a library of your room. See that place you watch TV a lot. Push some things away. And get books. Books you don't even understand. Put it there. Have romance with knowledge and be pregnant. Have an intercourse with knowledge and become pregnant with wisdom. Have an intercourse, romance with knowledge and be pregnant with wisdom. And when you open your mouth, the world will gravitate towards you. Knowledge is light. If you don't know, it's sacred. Knowledge is sacred. The wisest and the wealthiest man who ever lived. Who can tell me? Adam, Edith, who is the wisest and the wealthiest man who ever lived? This is knowledge.
I'm using the Bible.
King Solomon.
I just want a name.
Solomon, King Solomon.
That's true. He said that fools hate knowledge. So sometimes I love learning, not academic. In fact, I read more books outside my academic career than inside my academic career. Okay. Maybe you have not seen my profile, okay, on the page, but whilst we are talking, I'll put that profile in. You see that I'm not just bookish. I don't just do bookish activities, but I love learning. And I want you to love learning, because learning, not money, learning, not money, is the foundation of life. Learning is the foundation of life. So be so much hungry to learn, because anything you are doing right now, whatever job, whatever, the problem is not the problem. The problem is your knowledge. Write this down. Effort is a common denominator. Knowledge is a differentiator. Effort is a common denominator. Knowledge is a differentiator. Good. Now let's begin. Are you ready now? Any questions so far? I baptized you guys with knowledge power. I hope you have enjoyed the initial encounter. You don't like it, you meet me again.
We have.
I've enjoyed it.
We have.
You see, I teach people this. I teach people this, and they pay me 19 people in 11 countries. Some of what I just told you. Some of them are business people. Some of them are academics. I teach them this. They pay me $5,000 every 6 months. I don't lie to you. So you guys are having some of them for free, because it's so inundated in me that I can't let it go. When I meet people, I just have to pour that to them, because write this down, because value will always return to the source of value. I know that. And I can't let it be, because it's burning. Value will always return to the source of the value. Let's start on supervised learning, because I know you are ready for that. But don't worry, I'll set the question for supervised learning. So whether we start or not, I will mark it, and I can say that don't even learn, and I'll give you a, isn't it? So don't worry, I'm the one in charge. What is your problem? I can teach you today, or I can decide not to teach you today, and I'll still give you a question and give you the answer, and you can pass it, you can get it. But that is not the key. The key is not learning, but learning how to learn. I don't know. Key. See, the reason why I keep saying write it down, is because people forget things. Because there's an information symmetry between your fingers and your brain cortex. You don't need to learn, but rather learn how to learn. Because once you learn how to learn, you can learn anything. Because knowledge is infinite. You are finite. You can die. Your knowledge will outlive you. But you can die. But your knowledge will outlive you. All right, so gentlemen and ladies, I want to welcome all of you here to the Valley of the Shadows of Unsupervised Machine Learning. My name is Dr. K. Oyo, and I'm going to be walking you through this program. I will also meet you in statistics. Okay, I don't think I'm taking your group, but I'll take the other group. I will also be meeting you in other areas. Next semester, I will also be teaching you 2 other subjects. Research methods and some other subjects. All right, so at this stage, those of you who wish, you can unmute, sorry, you can turn off your screen, but you can also continue, because the more I see you, the more I am more motivated to talk and to teach in the process. But at this stage, it's not by force. You can, turn off your screen if you want to. But I want to still see those who stay on. Okay. Sometimes somebody will say that, Master, I want to turn off my screen. I just go, onka. All right. So, wait, how do you turn off this? Hold on. Looks like I need to reshare my screen. So, What we want to do today is a very, very simple thing, okay? And that is artificial intelligence, machine learning, deep learning. These are all important things you want to know. Okay? And I know that maybe some of you have heard about it, but we are going to look more into these things. I want you to understand machine learning because it's one of the huge aspects of AI. And business analytics is an embodiment of that. So you're going to understand things related to machine learning. You're going to look at both supervised and unsupervised machine learning. This course itself is for unsupervised machine learning. Next semester, you will do supervised machine learning. I'll be there as well. And then within the unsupervised machine learning, which I'll use graphs to explain it to you, don't worry. There are a lot of things there, such as segmentation, clustering, similarity, principal component analysis, and several things that we shall be doing. Process. So first, what is AI? Mr. Santi, on the screen, what is AI? Guys, I'll call you. Anybody I call and the person doesn't respond, my system will give the person -2. So just be ready.
AI is a broad field of computer science that aims to create machines or systems capable of performing tasks that typically require human intelligence.
Good. I want you to watch this, Ruth. What is this?
A phone.
A phone. Good. Is it intelligent?
Yes.
Hmm?
Yes. Yes.
Esther, this thing I'm holding in my hands, is it intelligent?
I think it's intelligent based on what you feed it.
Is it intelligent?
I think it will be intelligent based on what you feed it.
Yeah. Yes or no? Is it intelligent?
No.
No. Brenda, is it intelligent?
On its own, I'll say yes.
Yes, this thing is intelligent. It's very intelligent. And let me ask you, Brenda, are you intelligent?
I am very intelligent.
Hey, now very now the town there, fine. Okay. So now let me go to Ohini. Ohini, you are intelligent and this thing is intelligent, right? So what is the difference between you and this thing?
I'm able to think on my own, but the mobile phone would need someone to operate it.
How would you know that you are good at something? Unless I ask you, what is 2 plus 2?
4.
Did you think?
Because I have learned it already.
Did you think?
No, I did not think about it.
Good. Now, if I ask this guy, what is 2 plus 2, it will also give me the same answer.
Yes, it would.
Both of you are intelligent.
Yes.
So what is the difference here?
The difference is that the mobile phone has been programmed by a human to be able to use a calculator to compute the 2 plus 2. But personally, I had to learn it to know that 2 plus 2 is 4.
That you're learning it. Is it not your programming?
Yes, it is my programming.
Because the computer to learned it and it was being programmed. And you went to school, you learned it and you're being programmed. Yes. If you can understand how the human mind operates, you will understand this course very well. Everything, I told you before, everything you need to succeed in life is already in you. It's already in you. So if the computer or the device, whether it's a robot or computer or a mobile phone or chatbot or anything, if that thing will be able to do well, it means that if that thing was created by you, if it was created by you, it means that you are better than it. So the issue is not about intelligence, it's about wisdom. Write this down. Sagacity does not connote intelligence. Saga Sagacity does not connote intelligence. The computer is intelligent due to your intelligence, but what you have is sagacity. Sagacity is sage, is wisdom. Is wisdom. And wisdom is not just intelligence. Wisdom is application of intelligence. Sagacity does not connote intelligence. The same way as taciturnity does not connote imbecility. Okay. So the whole broad area of AI, okay, it is using computer science, but not just computer science. It's my internet. Okay. You are creating machines, and these machines are not just robots, as we always think. A car is a machine. This mobile phone is also a machine. This remote is also a machine. Okay? All of them are machines. And you are creating this machine to do work as though humans should have been the ones to do it. That broad thing is known as artificial intelligence. And it started a lot in computer science and robotic engineering, but now it's gone into several areas. And what a computer can do is so marvelous because it can do what is known as reasoning. Logic, it can do it, which is the same thing human beings can do. It can solve problems human beings can solve. It can understand natural language processing. It can do that. It can do pattern recognitions, and it can decide. In fact, there's a machine, there's a car that can distinguish between 80 types of snakes when it crosses the pathway. And it will not kill only one, it will kill the 17. Because it knows that one of them is not poisonous. Can you imagine? So it's so intelligent to be able to distinguish that. But you who is driving the car, you kill all of them. The ability for us to be able to combine this knowledge for that machine is the reason why we are here. So I want you to understand something about AI. AI uses a lot of approaches. It uses something known as expert-based systems. Okay? Expert-based systems, symbolic reasoning, knowledge representation, and the most favorable one, machine learning. Machine learning. What is a rule-based system? Rule-based system. Okay, when we talk about rule-based system, we are talking about the earliest form of AI. That is designed to mimic decision processes of human expertise. The rule-based expert systems operate on a set of predefined if-then rules. Okay? If-then, and you normally get this from expert knowledge. So the person must be an expert knowledge before you can now let the person use that to go into the computer. For example, you can say that if the rule is, if temperature is greater than 100 degrees, okay, and the pressure is greater than 50 psi, then activate the cooling system. That's what you can tell the machine that the moment, for example, when you are driving a car, some of you drive, and when you are driving a car and the car is speeding, it looks at the distance between where you are and the next car. And then most Benz cars, it will start, isn't it? To give you a warning that you are getting too close. That is an expert-based system, and it uses that. There is also symbolic reasoning, which are indicated. Normally, they call it good old-fashioned AI. Write some of these things down. Good old-fashioned AI. That's symbolic reasoning. It focuses on manipulating symbols. You manipulate symbols. Abstract representation of concepts. Use logic to derive new knowledge. Use logic to derive new knowledge, and then you solve this knowledge. That is symbolic reasoning. They call it good old-fashioned AI. Go-fi. Good old-fashioned AI. And then you have the knowledge representation. That one is the art and the science of encoding information. The science of encoding information in a form that the AI system can use for reasoning. coding information that the AI system can use for reasoning. That is it. As for machine learning, we are going to look at that, so I will not talk about the machine learning. But all of this, we are going to go deep into them. So when we talk about AI, artificial intelligence, it can be both rule-based, the one that is explicitly programmed, the one that is based on logic, and it can also be learning-based, okay, where you learn from the data, which is the machine learning that we are going to be doing. So this is AI. Now you have to understand AI, but if you don't understand AI, I'm going to show you a graph that will give you a better understanding. Somebody writing on the screen. You see that on the white. Okay. So I'm going to give you a picture representation of that. Now, please, I want you to know that machine learning is a subset of AI. AI is broad, and machine learning is a microcosm of AI. Okay. Let's take this picture. So if you look at the deep blue, that is the entire AI. And you want to understand this one time. And if you don't understand this, please raise your hand and let me explain. The entire blue is the entire artificial intelligence. Inside artificial intelligence, you have machine learning. But machine learning is not the only thing that is inside artificial intelligence. Who can tell me another thing that is inside artificial intelligence? Who can tell me? Another thing that is, I know some of you will have a fair idea before coming, but don't worry if you don't. Who can tell me another thing that is inside artificial intelligence aside machine learning? Yes, Ebenezer, I knew somebody is here.
Data science.
No. Data science is inside and outside. Data science is like business analytics. Business analytics is just data science, but for businesses. Data science is more in computer science and mathematics, but business analytics is more in business tools. But there's something. Yes, Gomashi.
Deep learning.
Sorry?
Deep learning. Deep learning.
Deep learning itself is inside machine learning. So it cannot be part of AI. It's part of AI, but it's already inside machine learning. But I'm talking about apart from machine learning, what are the other ingredients of AI? It's not here. Oh, it's not here. Computer. Yes, Jennifer.
Yeah, I'm thinking natural language processing.
Excellent. Very good. Okay. Text analytics. That's one. Text analytics. If you don't know, write it down. You see, Jennifer just gave you something. And if you don't know, write it down. So text analytics. What else? What else? Aside machine learning, what are the other ingredients of AI? Joseph.
Robotics.
Robotic engineering, okay? Robotics, excellent. What else?
Dog.
Yeah.
Can I also say vision as in sight?
Exactly, computer vision.
Yeah.
Computer vision. Guys, if you don't know, write it down. Kofi Medu has just opened his mouth and vomited some knowledge into your coconut.
Yeah,
Yours is to document that coconut. Document that knowledge inside the coconut. What else?
what about forecasting?
Who is talking?
It's senior.
Here we raise hands and then we talk. Kofi, your hand is up again.
How about automation?
Automation. Yeah, that's similar to robotic, okay? But that's it, automation. I'm going to ask somebody to mention all. So please take note. What else? Expert systems. Write it down. Expert systems. Joseph, you have one.
Yes, sir. What about neural networks?
Neural network is still inside machine learning. But I know sometimes you can have it a bit separate, so I can buy that. But the general name for it is speech recognition and understanding. Okay. Speech recognition and understanding. They use a lot of natural language processing also there. But there's another one. You have to know.
Computer vision.
Please raise your hand. Raise your hand. Raise your hand. Because if I had muted you, you would have raised your hand. So raise your hand.
Sorry, so sorry.
Raise your hand. And then I'll call you. I need to know the people I'm giving the marks to. Yes, Ado. Fitnat. It's Fitnat in it.
Yes, Professor Neil.
Okay, go ahead.
How about computer vision?
Computer vision, as we mentioned, is true. It's one of it. Okay. Another is planning and optimization. Write them down. Planning and optimization. Planning and optimization. And there's another one called KRR. KRR. And fuzzy logic. Fuzzy logic. So all of these are content of AI. But you see, the one we are focusing on is what? It's just a machine learning part. Now, when it comes to machine learning, the inside it is also deep learning. And inside deep learning, you also have generative deep learning. Okay, but we're not going there. Just understand that business analytics and data science, a portion of that is inside artificial intelligence. But it's not all of it that is inside that. Business analytics and data science also have other things artificial intelligence doesn't have. Who can give me one thing? In fact, all of you are doing it, so you know. Take some of your subjects. Mention one thing that is within business analytics. It intersects with artificial intelligence, but it has certain things AI doesn't have. And AI has certain things too that it doesn't have. What is one thing that business analytics or data science have that AI doesn't have? You can tell me. Just take business analytics. Don't take data science because you are doing business analytics. What is it that you are doing that is not technically AI? But some of your courses clearly show that. You can give me one. Yes, Joseph.
So I'm thinking of probably the application of statistics to take this business decisions.
As for things in statistics, they are all AI. There is something in your course. Grace, your hand was up. Brenda.
Would that be programming?
Oh, programming is all AI.
It's all AI.
Take some of the courses you do that are not. Yes, let me go to Godfrey.
I'm thinking strategy for.
Excellent. That's it. Strategy. What else? What else? Who is called user? User, I need to know your name. User is not your name. Yes, I do know.
So what about financial management?
Financial management, exactly. It's not AI. It's business analytics, but it's not AI. What else? Jesse.
So can we say marketing?
Marketing, absolutely. Marketing. Yes, Rama.
Say HR, human resource.
HR, very good. It's not really AI. Richard. Database management. Data. In fact, that was the one that should have come first. Database management. So that's it. Oh, you still have more people. Let's go to Magnus.
Supply chain management.
That one is too broad. That one is even beyond business analytics. Everything in life is management. Gibraltar.
Financial management.
Financial management or finance. So that's it. So you can get the idea. So I want you to be able to get that. If I tell you to sketch a Venn diagram showing the connection between, watch it, showing the connection between data science, artificial intelligence, machine learning, or showing the connection between artificial intelligence, machine learning, and business analytics with 5 examples of each. You should be able to do it. Now let's go to the machine learning. What are some of the examples in machine learning? Well, one of them is logistic regression. You shall learn that next semester. Another is K-means algorithms. You shall learn that next semester. Another is PCA. It's all machine learning. Principal component analysis, random forest, support vector machine, ADA boost, CAT boost, SG boost, K nearest neighbor, decision trees. All of these are examples of what? Of machine learning algorithms or machine learning models. And of course, when we come to artificial intelligence, you remember we have listed about 10 of the examples in there. And when we come to business analytics, we've also listed about 6 of them. You should be able to know which ones intersect. You should be able to know which ones. If you have a question, you can ask. Now let's go to machine learning. That is the focus. Because remember, the course we are doing is known as unsupervised machine learning. So we need to understand machine learning. So it's time for machine learning class. Stop misbehaving, sit up right, because it's time for machine learning. What is machine learning? In fact, first of all, why do you have to learn? And what is machine learning? What is the difference between machine learning and artificial intelligence? Well, that one, somebody can quickly tell me. Someone, what is the difference between machine learning and AI? Who can tell me? Yes, Sammy? Sammy, if you don't know, just say pass. What is the difference between machine learning and AI?
Hello, sir. Can you hear me?
Yes, loud and clear.
Okay, all right. So in my thoughts, machine learning is more of programming a system to absorb knowledge.
Now watch the words. Watch the words I just said. What is the difference? What is the difference? Don't define this for me and define this for me. Get the distinguishing difference. We are done. Okay, think about it. Let's go to Benjamin.
Machine learning is a facet of AI.
That's it. When you ask certain things, it's about bringing whether one is a subset of the other, or one depends on the other, or the other depends on one. As for their definitions, we know. Because everything about machine learning is what? Is AI. That's the point. But not everything about AI is machine learning. Write it down. Everything about machine learning is AI. But not everything about AI is machine learning. Now we come to the definition of machine learning. What is that? Okay. Machine learning programs computers to optimize, that is either minimize or maximize, a performance criterion using an example, past data, or present data, even sometimes even future. Watch the word. You are programming the computer to optimize performance. So if you want to calculate payroll, there is no need to learn to calculate payroll. The machine will do that. When you are doing learning, you can use human expertise, but human expertise does not exist in certain areas, so machines can do that. For example, if you have to go to Mars, humans have not developed the expertise to go to Mars effectively. So we can't just go like the way we all go to Makola. And so that is where machines can be programmed, or computers can be programmed to be able to guide us, to help us. But you can't program a computer to give birth. That one, humans have mastered, learned naturally how to do that. I will not program a computer to be pregnant. Aduba, can you program a computer to be pregnant?
No.
Yeah, but can you be pregnant?
Yeah.
So there are certain things we are not good at, but the machines are good at. There are certain things the machines are not good at, but we are good at. Humans are unable to explain their expertise. For example, how do you recognize the difference between GAN and EWE? What is the expertise? What expertise do you can't even recognize it. You don't even know. Sometimes you learn. Yes, you know how to learn, but you don't know how you are able to learn how to learn. Are you guys with me? You know you can learn, but you can't even explain why you are able to learn. It's called unconscious competence. Not when you're starting to drive a car. The first day you hold the car, you're holding the steering wheel like this. Hey, don't talk to me, don't talk to me, don't talk to me. Okay? But as you now move away from that level, you now become competent. You unconsciously drive the car and you're making a call and you're eating chips whilst you're eating. You see, you are driving the same things you are doing, but unconsciously. Learning. That's what I told you earlier. Hosea 4:6, lack of knowledge, my people perish. So learning, not money, is a foundation of every success. Now, let's move on. What we talk about when we are talking about learning, what do we mean when we talk about learning? Learning, okay? Now, if you want to learn general models, you can do that from a data of a particular examples. Now, why do we use data? The reason why they call it data science is because data is cheap. Data is very cheap. It's also abundant. We have a lot of data houses. Now we have data and big data analytics. We have data math, like Superman. Okay? We have data math. But even though data is there, knowledge is expensive. Knowledge is scarce. Because right now there's something you know I don't know. There's something I know you don't know. Knowledge is not cheap. Now, which one is more powerful? Data or knowledge? Godfrey, which one is more powerful? Data or knowledge? Carla?
I'll say knowledge.
Yeah. Knowledge. And that knowledge depends on you having what? Data. Let's take, for example, a retail shop, Accra Mall, supermarket. Okay. And a customer is transacting a business. So customers' transactions to consumer behavior. Okay. We know that people who will buy Da Vinci Code, they also usually bought the 5 people you meet in heaven. It's a book. Amazon uses recommendation system. For example, some of you already know this. If you go to DSTV right now, and they see that, not DSTV, Netflix, okay, and you start watching comedies, what do you think they will start recommending for you? Comedies. They have seen your behavior. That's why we normally say Satan is powerful. Satan sees your behavior. And Satan uses an AI system called pattern recognition. So when you now see that you like Akbatechi a lot, you like Akbatechi. Gamali, do you know what I mean by Akbatechi? You look like you are a foreign, an American man. Godfrey, are you an American man?
No, American.
And so you know Akbatechi?
Yes.
When he sees that you like Akbatechi a lot, wherever you pass by, you will bring Akbatechi color. You know. The day that you decide that you want to quit alcoholism, that is the day somebody dies. And now you have to go to a funeral and go and reignite all the muscles again. Because he's recognized your behavior. That customer behavior, which defines the way they do businesses. The same thing as you see in Netflix and other things. This is a system called recommendation systems. And we shall do that next week, which is known as similarity index as well. So you can build a model that is so good, that is useful approximation to the real data. The data is a customer transactions, and you can use that for that purpose. Another aspect of machine learning is knowledge discovery in database. Now, what is KDD? What is KDD? Let me ask someone. What is KDD? Samuel Addo. What is KDD? Someone, don't worry, just read. What is KDD? You know, when the thing is on the screen and you feel like you don't want to say what is on the screen, you start getting it wrong. So just read. Samuel Addo, are you there?
Please, I'm here.
Yeah, tell us, what is KDD?
So, KDD is the non-trivial process of identifying valid, novel, potentially useful, and potentially useful.
Is it that you don't see? Or the words are too big?
Please, I'm having a bit of a challenge here. That's how come. But
Okay.
potentially useful, ultimately understandable patterns or knowledge in data.
The way you have read it, even you yourself won't understand.
Yes, please.
So what is it? What is KDD? Guys, KDD encompasses a multidisciplinary approach which involves data mining. You do that. Machine learning, statistics, visualization techniques, all of that. Okay? They use these things to extract actionable insight, knowledge from raw data. Okay? It started somewhere in the 1980s as a response to the growing need to handle massive data set. Big data analytics was coming. Huge data set, and not just data set, but data sets in databases. Yes, Benjamin.
Would you say knowledge discovery is the same as data mining?
No. Data mining is used to achieve knowledge discovery.
Okay.
Okay, so the knowledge discovery is a kind of an end result. But let's say it's Kumasi you're going to. But before you can get to the Kumasi, you need a car or an aeroplane. The car or the aeroplane is a data mining. The Kumasi is a knowledge discovery. Are you with me, Opele? Okay, so that is data discovery. And there are quite a lot of applications. You can apply it to retail, to finance, to manufacturing, medicine, telecom, bioinformatics. Okay? You can use it for web mining, search engines, the Google and Safari, all of those things that you use. Yeah. Now let's go to the machine learning proper. What is machine learning? And I'm emphasizing on this because once you understand this, before we go to the unsupervised and supervised, okay? Machine learning, as we've consistently been saying by now, you should know, is a subfield of AI that allows computers the ability to learn, watch this word, without being explicitly programmed. That is very important. What do we mean by without being explicitly programmed? Who can tell us? What do we mean by that? Okay. What do you say you're allowing computers to learn without being explicitly programmed? What does that mean? To say that without being explicitly programmed. Pascal, without being explicitly programmed.
Doc, it means probably with little or no code restrictions.
Say it again.
I'm saying it means with little or no code restrictions within it.
Okay, well, what do you, please don't say it as if you are telling me, but say it as if you are teaching your colleagues. Because what you said.
What it means is that with machine learning, you can initiate the program by giving it rules as to what to do, and from there it can carry on. Or you can allow it to learn on its own without any restrictions or giving it any rules. That's what I mean.
Very good. William, what do you have?
So I think that without being explicitly programmed means that the machine has the flexibility to be creative and not to be fixated to one pattern.
Very good. So who can think of, okay, let's go to Edward.
I think without a lot of human interference, in terms of after it has been programmed, it will be pushing out on its own without the human interference.
William, your voice is so far. Nobody heard you. Okay, so let's say that who can give me an example? Because an example is more efficacious than precept. can give an example. Justice. Example. Justice Kwijo. Grace Klubi.
Okay, so I was thinking that, for example, when a program is written, it is limited to a specific database, but for machine learning, it can go through different sources and then give
Most of you
results.
are talking without giving me a real practical example. Let me finally see what Caroline can do. If not, I'll just give you an example. Yes, Carol.
Yes, thank you very much. So let's say you have an AC. I'm just a lay example, and there's an explicit instruction, more like when it's maybe 30 degrees Celsius, you can turn on the fan. Or let's say you want to take breakfast and a slice of bread, take 3, and then maybe just 3 slices, and use margarine in it. Or take 5, use margarine, put it on a tray. Those are explicit. Those are specific instructions.
Very good. Very good. Now I see more hands. Very good. Enoch. Saibu. Okay,
Hello, sir. Hello.
Yeah, Enoch. Pay attention quickly.
Yes, sir. So for example, Netflix, so it identifies your watching habits and the movies you like, and is able to predict the like similar movies for you. So that could be an example of machine learning. So it kind of learns your habits and your interest, and it suggests similar movies so that you can watch those movies as well. That's what I think.
Okay. Fitness.
Yeah, so Prof, I was thinking on the shopping websites, sometimes when you purchase something, they suggest other things, like they'll be like people who bought this also bought that. And then maybe, I don't know if the keyboard, when you are typing and then the keyboard completes the word or the sentence for you. I don't know if that could also count as that.
Very good, very good. So let's assume that you are writing a program, okay, to detect spam emails. Please, you all know spam emails. Samuel Agbo?
Yes,
yes. Okay, good.
Yes,
Doc. So you're writing a program to detect that this email is a spam. In traditional programming, you might write something like, if the email contains the word lottery, mark it as a spam. Traditional programming. Or if the email contains words like congratulations, you won, because you know that is already what is spam. So you program it. And so once you program it, the moment any email you get, that counts congratulations, you won. It will mark it as what? As a spam. But this quickly becomes impossible because spammers can change the words, okay, and styles very constantly. They alter it. So if you're going to do that, you're going to write a lot of programs. And that might be a very bad thing. So what machine learning can do is that instead of writing the programs yourself, you show the computer many examples of spam emails. Get a point? Many examples, 10,000 or 100,000 spam emails. Then you also show 800,000 normal emails, those that are not spam. And then you give it to the computer. And then the computer will now learn the patterns automatically. You are not going to do anything. You give it to the computer that these are 10,000 spam emails. These are 10,000 non-spam emails. Learn it. Now that it has learned, any email that comes, it can detect whether it's a spam or it's not spam. Please, are you guys with me?
Yes, sir. We are here.
Yes, sir.
So that is what we mean by that. That is what we mean by without being explicitly programmed. And machine learning is that field that helps you. Okay, so the ordinary system will come in with AI. Then inside the AI, you can now have machine learning. And based on the machine learning, it will learn, it will predict, and of course, it will improve in the process. But this is a very beautiful, typical example of that. Now, yes, Brenda.
Yes, Doc. In the previous two slides, you gave some examples of, I think I saw CRM, I saw credit scoring, and I'm just trying to figure out how that, what it plays in terms of machine
How
learning.
is machine learning connected to this?
Yes.
We'll do that. In fact, some of you will choose a thesis, a dissertation related to that. Let me take, for example, fraud detection or credit scoring. Which one should I take?
Credit scoring.
Credit scoring. What is that?
Okay, so for me in telecoms, we look at a set of data presented by the customer to determine whether to give a service or not. So let's say the customer is coming for dedicated internet. Would look. Say it again.
The customer has got a probability of default. So why are you checking the background of the customer?
Okay, for credit worthiness, that's one.
And what are you going to do for the customer? That you are checking whether the customer is credit worthy.
We are providing a service for which you need to pay monthly bills for. And so we need to know whether he has the ability to pay his bills at the end of the month.
Good. Now, a typical example is a bank, isn't it? When a bank wants to give a loan and they want to check whether the person has got the possibility of defaulting the loan, isn't it? It's similar. Now, you can use a machine learning algorithm, machine learning model known as logistic regression or random forest or support vector machine or ADA boost or cat boost or extreme gradient boosting. All of these machine learning, you can use it to detect. So you will have a data set, and that data set has got this guy defaulted, this guy defaulted, this guy did not default, this guy did not default. And now, based on this, you will now know what factors led to the default or not the default. So you can create a machine learning model to predict that with these other people coming, based on their characteristics of the previous guys, and these people also having similar characteristics, I don't think they will what? They will default. Or I think they will default. The model can predict nicely for you which factor is even critical, okay, in determining the default. For example, if a person does not pay twice, could that signal the probability of default? Okay. So it will tell you upon all the characteristics. So you can list as many characteristics, and then you'll be able to know which one is the most influential characteristic in leading to the probability of default. And the models are there. And so the machine learning models are the ones I gave that can help you. And you can apply this in your work, and you can use that to even run your monthly programs every day to know which people are likely to default or which people are likely to. The same thing with fraud detection. Okay. For example, somebody orders some money. This person has not been taking big money. I remember this time I was in the UK and I wanted to, cash some. I wanted to cash some 10,000 pounds, and I wanted to bring the kind of questions they asked me. My own money, okay? Because such kind of transactions we hardly make. So you got to go through. But you see, this one, machine learning can catch you. When I start teaching you next semester, I'll be teaching something called financial analytics or analytics for finance. Or you see a lot of these things. I'll show you real life data. Let's move on. So machine learning is very, very important. You can use it to do so many things. Behind the scenes, it is using mathematics, it's using statistics, it's using computer science. Just know that, behind the scenes. So your mathematics background, it shouldn't be too much mathematical, but at least you must have some grounding of mathematics. That is why you guys are doing statistics for business analytics. You must have some grounding. So if you don't like maths at all, it means that Aquila. Have I given you guys Aquila to go and refresh your mind? Please remind me on the page that I need to, because I've given those I teach statistics for business analysis. I've given them Aquila to go and refresh the soft copy. So that you can, you are laughing. I mean, Aquila is laughing, blah, blah, blah. You will learn Aquila maths, especially simultaneous equations, and then, word-based problems, vectors and matrices. You will have to learn it. All right, now let's go to the types of machine learning. Senor.
Yeah, Doc. So please, with the examples that you feed your machine for it to detect spam emails, does it mean if you have some that is falling out of the example you have fed it with, it will not be able to detect for you? Or based on the pattern that you
There's
feed
so
it
many
with?
examples. Give me one that you think would not be falling. There are so many, I can't even list them all.
Okay, so based on the pattern of examples that you feed the machine, it's able to predict if there are other kinds of it.
Yeah.
Okay.
Oh, yeah. There's a lot of predictions. Forecasting, they want to get to forecasting, you see the models that are there to, you can see, you know what? That's why sometimes when, certain things are not happening in the government, academics will know that the reason why the things are not happening is because of corruption. That's why, because there are models there that can be what, even if there are uncertainties, even if there are stochastic phenomena, noises that are difficult to model, you can still use Bayesian statistics to be able to model them. But it's because human hands are operating, they're letting the models operate. It can determine, see, I can build a model for you that can determine the worth of every person in your company. How much worth is this guy? How much money should he be paid? How much worth is this guy? All I need is just a 1 month data. And you will see that some people have been overpaid and others are being underpaid. You can determine the salary structure of people. So the models can do that. The models can do that. All right, let's look at the types of machine learning. We have supervised and unsupervised. What this course is about is unsupervised. But first, before we talk about unsupervised, let's get a feel of the supervised. Supervised is some, guys, I want you to know the difference between the two. I promise you, if you get the difference between the two, is good. Why is one called supervised? Why is one called unsupervised? So, normally, I'll let you read it because this is key. Everything we're going to do is based on this. If you learn from the labeled data, watch the word, labeled data. You are learning from a data and the data has been labeled. You are learning from the data and the data has been labeled. You are learning with the intention of predicting. You are learning with the intention of classifying. Then this is supervised. The key point is labeled data. Labeled data. So what do I mean? I'll show you an example very soon and you will appreciate it. Okay? And when you learn from that labeled data, you can predict the next one. Or you don't even want to predict, you can classify. You can classify those that are foreign banks. So all the banks are mixed up. Okay? And when you learn, you can now classify those that are foreign from those that are not foreign. Because you can look at the capitalization of the banks, and you see that this group, the market capitalization or the amount of money you must have, they are all having above $100 million. But this group, they are all having below $10 million. So now you know that, according to the central bank, the foreign banks must have more than this amount, and these ones must have. So that can easily help you to be able to classify. Okay, let's call these people, or those with a total asset of about 2 million, and those with a total asset of about 10 million. You can use that. So that's the data because it's been labeled as what? Total asset. So when you go to the top, you see that column, total asset, 250,000. You can see the labeling. So now you can use the label to classify them that, oh, this guy is a small bank. This guy is a big bank because they are labels there. Mm-hmm. And that's what that aspect is called classification. Okay? And then we have another aspect which is known as regression. Regression is when you're looking more at causality. Okay? And using it to predict. And classification is when you are splitting them. So you can do a lot of image recognition is also another example, spam detection, and all of that. We shall look at all this next semester. But this semester, we are looking at unsupervised learning. Unsupervised is unlabeled data. So the data is not labeled. It's manya, 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 manya. And I'll give you examples today. And what you got to do, guys, is to find latent patterns. Latent, hidden, unseen. You see, the other one is seen. You know that this guy is total asset. So if I put some numbers down, you don't even know whether this number is total asset and this number is a dividend and this number is profit and this number is that. You don't even know because it's all hidden. But then there is a way you can analyze, categorize, group them, cluster them, reduce the size, coagulate some of them, and then you'll be able to say that, oh, this one is that, and this one is that. And so unsupervised learning tries to analyze the unlabeled data. The final aspect of machine learning is reinforcement learning. This is where the model will learn through trial and error. There's a lot of trial and error. You receive reward. So it will tell you that if you do this, you get a reward. If you do that, you get a punishment. So you are learning from the interactions, given the environment. Reinforcement learning learns from the environment. And it has a reward or a penalty based on the action that is taken. And we shall look at that also next semester. So what is the difference between supervised and unsupervised learning based on the little I've given and based on what is on your screen now? Tell me if you are looking at the differences. Tell me what is the main difference between supervised and unsupervised? Yes, Esther.
With a supervised one, it has labels. And with the unsupervised learning, it doesn't have label. So you determine the hidden patterns.
Okay. So what are you looking for in unsupervised? What are you looking for?
So is the question to me? Oh.
No, it's to everybody. What are you looking for? I like the way he says it to me. You don't want to holler. Okay. So what are you looking for in super? What are you looking for? Grace.
Yeah, trying to find a structure or form or trying to find a pattern from cluttered data that is not labeled.
Good. And in the supervised, what is already there that you're not trying to find? What is already there? Gamali.
The supervised, because already labeled, you don't need to group them already, it's already clustered.
Yeah, so what is already there? You're right. What is already there? Angela.
Categorize data.
A structure.
Or
pattern.
That's it. Okay. So you are using what is already there, the pattern, the structure that is already there, and you are now going to make use of that to predict or to establish causality. So get the two. So which one do you think is difficult? Which one do you think is difficult? Don't guess. If you are guessing, stop. Richard. Amma. Sorry, I can't hear you. What do you say?
He said unsupervised.
Unsupervised, that's it. That's it. Guys, you'll be surprised to know that that is not really necessarily the case. It can turn the other way around. It depends on which aspect of unsupervised you're looking. So, machine learning is growing significantly. Okay? When you are doing things related to speech recognition, you will need it. Natural language processing, text analytics, you need it. Computer vision is an aspect of AI, but still use a bit of machine learning to support that. Medical analysis, you want to tell the probability of somebody having a cancer or diabetes. Looking at all this trend, I think you're going to have cancer. thinking about all these things, and you are going to have diabetes. Machine learning is used a lot in health analytics. Robotic control. I've told you an example of a car detecting between, a poisonous snake and a non-poisonous snake. Yes, Swansea. Swansea.
Yeah, hello, Doc. So just to backtrack a bit, you were saying that the unsupervised learning might not necessarily be difficult than the supervised. And I'm still thinking, how can something that is that doesn't show a pattern and something that shows a pattern already, how can that one be easier to handle than the one that already shows a pattern? Because you're saying it is not necessarily the case sometimes.
It's not necessarily the case, Master. I will prove you. When I start showing you the supervised, you look at the model, you start saying, yeah. Okay. You see it. You see PCA, class strength. These are all unsupervised. Similarity index. But when you start coming to regression, when you start coming to extreme gradient boosting, ADA boost, cat boost, random forest, support vector, all of these are supervised. You will see. That's next semester. Don't worry. I told you about knowledge thing, okay? I said knowledge is the only asset that creates and multiplies all other assets. Don't worry. You might even change them. You see, I know how people think, because the thing is unsupervised, then we are dead. No, it's not necessarily the case. In fact, it's probably even the opposite. So there's a lot of trend that is happening. There's a lot of machine learning that are increasing. Now we have double machine learning. We have generative AI that are there. We have softwares, that are too complex to even write by hand. We have new sensors, new input-output devices. We have demand for self-customization to the user. And so many things are changing. So machine learning that you are learning, guys, is growing. That's all I'm trying to say. It's growing. It's not static. It's growing. You've got to move in tandem with the growth. So look at the entire branch of machine learning now. You see the models you'll be learning. I will not focus on the supervised. You'll come back to it again. So I'll drop the supervised and the reinforcement. I want you to look on the far left section here. That's my interest. The things you are going to be learning are here for the semester. You will be doing things related to recommender systems. You'll be doing things, and all of these are into clustering. In fact, generally, you'll be doing clustering. You'll be doing that. We'll hint a little bit on that today. Dimensionality reduction, okay? We'll do that. Things related to principal component analysis, factor analysis, all of that. Structural equations modeling. All of these are unsupervised. These are only the techniques, though. The techniques. Remember, I told you that the technique is the vehicle in which to achieve the end goal. And so these are the vehicles. So clustering is a technique. The same way as money itself is nothing. Money is a tool which you use to achieve something. So when you're in the desert, and I give you $1 million, and you're in the desert, and the next walking distance is 1 week, and I give you $1 million, and I give you 4 gallons of water, which one will you take? The answer is obvious, isn't it? So you see that money itself is a tool. It's nothing. Money is nothing. So money is nothing. It's just the value. It's an exchange of the value provided. And so one must look at the tool. And once you have the tool can help you to achieve something. But the tool is a tool. The tool is not the most important thing. The most important thing is the end goal, what the tool is going to help you to achieve. So these are the tools for machine learning. Now let's look at a bit of the tools for supervised. We've already indicated that in supervised learning, you have a classifier, okay, and it deals with label data. We've indicated that, and your goal is to train the data. You train it until that data has learned enough to be able to now be used to predict subsequent things. Okay. And that is generally what supervised learning is looking at. You are trying to create a model to predict. And when I say to predict, for example, you can predict demand. You can forecast interest rate. You can forecast the depreciation of the dollar or the cedi, exchange rate. You can, anything that you don't see, okay, you can forecast it, provided you have something you have seen. So you are, the reason why we call it supervised is because it's like a teacher who is guiding a student. Right? When you start writing your dissertation, and somebody will ask you one day, so it's good you are writing a tester. Okay? I hope the others write it. The reason why it's called supervised is because it's like a teacher who is supervising a student to do something. And so you are guiding the data you collected, the label data, and you are helping that data to be able to tell you something you don't know. That is why it is called supervised learning. So is learning all right? The algorithm, the classifier is learning, but you are supervising it to do the learning. You are supervising it to do the learning. And that is why it is known as super. This model will closely mimic an intuitive human approach to learning that we have indicated, especially when you go to kindergarten. You know, the child can do it, but you are supervising more of the child to be able to draw. So sometimes you hold the child's hand, and then when you hold the child's hand, you say, move it this way, and then move it that way, and then move it, then you leave the child. Then the child would do, sometimes the child will even do something, so wow, you yourself, you couldn't have done it. That is the predictive part. Okay. And the models for doing this are regression, classification. There's a difference between regression and classification. In fact, let me just quickly mention, even though we'll learn it next month. Regression deals with numbers that are continuous or integers. Regression deals with numerical data. Let me put it that way. Numerical. Regression will have a target variable. So you have a target variable, y, and that target variable depends on an x, which is known as features. But let me take a practical one, then you can appreciate it. Because sometimes when people do math small, then you are dying. Okay? So let's take quantity demanded of a commodity, which is a function of what? Who can tell me? Quantity demanded is usually a function of what? Before you buy the iPhone, you demand the iPhone, you look first at what? Benjamin?
Price.
The price, exactly. Of course, you will agree with me that the price is not the only feature, isn't it? There are other features. You look at the price, you look at, the size, you look at this, you look at whether it is AI and all of that. But let's assume that this is the case. So the quantity demanded is called a target. Write it down. This is the beginning part. And then the price is called a feature, and there are several other features. In fact, in normal regression, we call this one the dependent variable, okay, the dependent variable dv. And then we call this one what? The independent variable. You did this one in your undergraduate, I think. But in machine learning, we tend to change the terms a little bit. So we call this target, and we call the other one features. Okay. Now, what is inside a target? This here, quantity demanded can be numbers. So they demanded 20 gallons, or if it is iPhone in a day. Okay. So let's take something else. It demanded 20 units of something, 30 units of something, 44.6 units of something, and then on and on. So in this case, the target variable is numbers, is numerical. Okay, and then it's dependent on what? Prices. But let's look at a situation where the target variable is not numbers. Let's say that have cancer, okay? Cancer or no cancer. Okay, so this one is no cancer. This one is no cancer. And this one is cancer. This one is cancer. So you have another target variable. But this target variable can be either cancer or no cancer. So in this case, it becomes a binary. When it is like a binary target variable, that is called classification. But when it is a numerical target variable, that is when we use regression. Please, do you get it? This is a warm-up for later. Okay, so that's the main thing under supervised. These are the two main things that under supervised that we dealt with. And the method for doing this, the method under each one of them. So you can have k nearest neighbor for regression, k nearest neighbor for classification. Support vector machine for regression, support vector machine for classification. So you can have support vector regression, support vector classifier. Okay? You can have neural network regressor, neural network classifier. Okay? Naive Bayesian decision tree regressor, decision tree classifier. Random forest regressor, random forest classifier. All of these methods can be used for that. If you have a question, you can ask. Yes, Senor.
Yeah, Doc, please, what do you mean by unseen data?
Okay. So you want to create a model when you are presented with unseen data. So it's beautiful. Let's say that you, right now, what is going to be the GDP of Ghana in 2026 and 2027 and 2028? You haven't seen it, have you?
No.
Have you seen it?
No, I haven't seen it.
That's unseen data. But we can actually predict that. But that is not the only thing. Unseen data can also be a situation where you collect data. Let's say you collect a data of 100 banks. And this 100 banks, you decide to split them into 70 banks and 30. You will run your analysis on the 70. You will do the regression or the classification analysis, everything on the 70. You put the 30 aside. You don't touch it. Then you create the model. You build a model with a 70. Now you have a model. And you want to now predict the model. You want to use the model for prediction. You don't use the 70. You now come and take the 30, which was not used to build a model. You use the 30 because you see, you are just telling me that you just built a model and you think the model is good. Of course, we have to pass the model through a lot of tests to say that the model is good. In regression, we talk about R squared, F test, all of those things to check whether the model is good. So you build a model. You are telling me this model is good. Okay, now let's use the model to predict. But to do the prediction, let's bring a new data. A new data. And this is the 30 observations that you took away. This new data now, we use this built model to predict what this new data is going to be like. And that is what we'll talk about. This is what we mean by unseen. Unseen here is not about unseen to your eyes. No, it is unseen to the model. The model you built has not seen this new data, but you are going to use the model you have built to predict this new data's outcome. So let me give you an example, then you can appreciate it. Earlier on, I spoke about quantity demanded is a function of price. Do you remember? Okay.
Yes.
You collect data on the quantity demanded of some gin bitters or burukutu, gin bitters. And they are 100. Out of that 100, you take 70. You build a model on the 70 quantity demanded and then on the 70 prices. You're able to come out with this regression model. Okay. The estimated variable is 250 minus 40 price. So this means that quantity demanded is negatively related to the price by 40. So you have built this model. Okay, so you have a model. Now your 30 data, they have not seen this model that you have built. And so now you want to predict this kill by putting price here. So this 30 observations, it also has data for kill and data for price. So you only take the data for the price. So if I drop the price here, what will be the kill? If I drop the price here, what will be the kill? If I drop the price, what will be the kill? We already have some kill data, but you are saying that if I drop the price, what will be the kill? And you want to check that kill against the true kill data you collected. And you hope that they will be the same. If they are the same, then this model you built is good because this 30 observation didn't know about this model. They didn't know about it means they have not seen it. And so when I present this data set with an unseen, when I present this model with an unseen data, it should be able to correctly predict these skills that are already. Are you getting some point?
So please, is this what maybe, let me say, Musa Dankwa is using to predict his post?
I don't know what Musa Dankwa is doing. What is he doing?
Okay, he was predicting, this election, to the election we ran.
I don't know which model he's using.
Yes, no, with the explanation you gave. So I was thinking maybe if he kind of used something of this sort.
Let's find out. I can't predict which algorithm he's using to predict.
No problem, thank you.
Yes, because the algorithms are many. There are about 30 of them. Okay, right? All right. So that's supervised. This is a typical example. Yes, Mousy.
Sir, please. So, in given the difference between the regression and then the classified.
Correct.
The formula you varied the target where it could be 2, then that becomes the classified. If I got it right.
Binary.
Okay,
like
but I have
binary, isn't it?
Yes, please.
Like male or female, or like cancer or no cancer, isn't it?
Okay. Yes. But what if there are several variables in the P section? Because it's looking more likely that could be. Okay.
There are several categories. Instead of male, female, you may let's say instead of married or single, you can have married, single, widowed, divorced, and all of that.
Okay.
Is that what you mean?
So the features could also be many. That's what I want to know.
Yeah, it could be many. It could be many.
Okay.
And there are higher levels of models that can handle it. So in this case, the technique that was originally used for the binary one, the 2, which is, say, logistic regression, you can no longer use the logistic regression. You have to use advanced models. Okay? That's why the random forest, the decision trees, and other models of machine learning will come in to do that.
Okay. Thank you, sir.
All right. So now I want you to look at this data set. As it stands, which one? Okay, let me put it this way. You should be able to tell me. What is the target variable? I know it's hard, but you should be able to get an idea. These are the ages of some people. This is the BMI, the systolic blood pressure, the diastolic blood pressure, okay, the HbA1c, the FBS, cholesterol, all the other elements. And now we want to see how these factors have an influence on the target or the dependent variable. What do you think? The target is 0, 1. It's binary. Okay? And so in this case, you have to use classification instead of regression. Please note, write it somewhere. When the target is binary, you have to use classification instead of regression. Unless the target was like numbers, plenty different numbers like this, then you are going to use regression. What practically is 0 or 1, but what target is that, William?
Whether they are healthy or not healthy.
Okay. All these things can determine whether or not a person is healthy or not healthy. And when you look at the thing, it might be some particular disease or something. Grace.
I was thinking whether the person has BP.
Oh, yeah. But the BP, we have systolic blood pressure and diastolic blood pressure already.
Doc.
You have an idea. It might be that. Yes, Kabir.
Yes, it's used to determine whether a person has a hypertension, is having hypertension or not.
That's what I had in mind. But I'm sure that is also what she had in mind, isn't it? Brenda, do you have a different one?
Yes.
Yes, I was thinking diabetic or pre-diabetic or yeah.
Very good. At least you know that it's two, it's binary. It's something or something. That's all you know. But this data clearly is an example of what can be used for predictive, for classification. Okay, let's go to the steps in modeling supervised learning. Yes, Abubakar. Enoch.
No, sorry, not to take you back, but I wanted to find out. So, let's say the target variable is binary, right? And so if you are creating a model, um, what is best practice? That's should you create a model to just target those two? I mean, the binary values, or you should create a model that can actually handle ones that are not binary, just in case maybe later in the future there are some changes and you have to, include other variables, so you don't have to recreate a different model
It's
altogether.
actually handling one, and the other one is deductible from the first one.
Okay.
It's actually dealing with one, and the other one is deductible from the first one.
So when creating a model, is it best you create one that just handles what you are
No.
focused on?
It has to be both. Because you see, somebody is sitting down there, you don't know whether the person has got hypertension or not. So the person gets the data. Looking at all of this, see, if I build a model, I will know the coefficient of each one of these variables. Do you know that?
Okay.
I will know, watch this. I'll be able to know that, let's say it's hypertension here. I'll be able to say that hypertension is a function of beta naught plus beta 1 age. Let's take age. Plus beta 2, the second one is what? BMI. And then I will keep going. Now I will know the value of this. Let's say it's 40. The value of beta 1, let's say beta 1 is 4. The value of beta 2 is 5. So I will now be able to say that now that I know the values, let's assume that I pick a person. Watch it all. Let's assume that I pick a person who has an age of 61 years. The person has a BMI of 22. The person has a systolic BP of 122 and has blah, 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 blah. Okay. According to this thing, the person is supposed to be what? No hypertension. Okay, that's 0, no hypertension. And 1 means hypertension. Okay. So I now substitute this thing and check whether the person is truly hypertensive or not hypertensive. I substitute. So what I'm saying is that you are building a model and you can use the model to predict a group of people. But because this one is binary, the model is rather going to tell you the probability of the person being hypertensive, or if there is a probability measure of the person being hypertensive, then you will also know the probability measure of the person not being hypertensive. That's what I'm saying. So I'm saying that there is no need to do it separately. They must all be here. Because by the time you get the model will tell you, if it tells you for one, it has also told you for the other. See, let me tell you, if I tell you that I'm not a man, you know that I'm what? I mean, we are in Africa. We are in Africa. I need to put that
A
out.
woman.
Exactly.
Woman.
I don't need to tell you that I'm a woman, but it's deductible. So if I tell you that I'm not hypertensive, okay, I'm not hypertensive. Oh, sorry. If I am to tell you that I am hypertensive, well, any one of them will. You should deduce that it means that if I am hypertensive, then you should know that I am not. You know what I mean? Like if I tell you that
high or low?
No, if I mean, we know when you're hypertensive and when you're not. But like I gave an example of the male or female. Suppose I tell you that I'm a gun. No. Because that one, there are so many other, what do you call it, tribes. I just want to see the thing is binary. Binary. I mean, you can, yeah, Irama. What do you have to say?
Yes, sir. For instance, height is either you are tall or you are short.
Exactly. So if I tell you I'm not tall, then you know that I'm what? You know I'm short. So you got to deduce that. So I don't need to collect data on short. So that's it. The model will tell you. Don't worry, we shall look at this thing deeply. And my interest is not supervised. Supervised is next semester, but at least it's good for you to know what supervised there. And the steps in going through all this is here. These are the entire steps. Yeah.
Not to cut you short, sorry. But in classification, there could be instances where there are some groups that don't fall within either category. That may be hypertensive or not hypertensive. So
Good.
the model, since it's predicting is looking at just two variables here. What happens to the third category that cannot be classified?
Yeah. Okay, so give me an example. If you're not hypertensive, then all of them fall into that group, isn't it?
Yes.
So why are you bringing a third group?
No, what I mean is that, so it's like
if I tell you that you're hypertensive and you're not hypertensive, unless you are talking about marital status, where you have more than two groups, single, married, widow, divorced.
Something like that.
Good.
Something like that.
So in something like that, then you're not going to use this logistic model to model the thing. You're going to use a different classifier, like random forest, like support vector classifier, like gradient boost classifier, like decision tree classifier. So in this case, because the groups are multiple, so you got to do multiple classifiers to be able to handle that.
Okay, thank you, Doc.
Okay. Hey, but we have not even done binary finish, and you're going, multi. Okay, so look at a typical example of classification. Credit scoring. You can differentiate between those that are low risk and high risk. Now look at the graph here. The theta one is the income pattern. Okay, so on the axis here, you have income and then you have savings. If a person is saving, is having more income, you move from the zero towards the right. If the person is saving less, you move from the top to down. Okay. So we can create a discriminant, or we can create a classifier, same thing. And so you look at observations here. We can categorize those that are low risk from those that are high risk. If an income is bigger than this theta value, if an income is bigger than this theta value, so you see, we've classified that any income that is here, it means that the person has got more income. And then we've also said that any savings that is above this, it means that the person is saving more. Okay, so here the person is having more income. And then the other one, the person is saving more. And if a person is having more income and saving more, then you will agree with me that that person is likely to be richer, isn't it? You agree with that? So watch those here. If they are likely to be richer, then they will have what? Low rates. So the low rate people are those that are having more income and saving less. Okay. Other than that, that person is having a high rate because the person is chopping everything. That's why I told somebody, when your mind has been tuned to be poor, poverty is not a state of money. I keep saying it. Poverty is a state of the mind. So don't say, I don't have money, I'm broke. It's your mind that is broke. It's your mind. Your mind is broke. Because that's why they say the rich gets richer and the poor. No, the rich get richer is not because the poor are getting poorer because the rich are getting richer. No. Okay? It's because you yourself, mentally, you are broke. Mentally. Poverty is multidimensional. You are poor in your health. Not just in your income or in your health. You are poor. You are poor in your relationships. You are poor in your spirituality. You are poor in your exercise. You don't even do exercise. You are poor in your eating habit. You look at most wealthy people, they'll eat small and they'll add this, they'll add this. You get hum. So the poverty itself is multidimensional. And so you'll be able to use classifier or a discriminant classifier model to be able to classify this. And I'm telling you, It can help you to know the category of people you should concentrate your attention on. And then if you want to give loans to people, you will now know that these people, and I'm telling you, the model, the software we shall be using, it will do the graph for you. Oh, don't worry. It will classify them. You even put the names of the people there for you. So you see, the Kofi Adunyame is actually a high-risk person. So, but you won't tell him, or if you tell him, you will die. So you have to make sure that you use that to make your own decisions. So this is a typical example of that. Classification has been used a lot. Face recognition. China is using that a lot. Japan is using that a lot. Singapore is using that a lot. Character recognition. Character recognition. Sometimes a person goes to the shop. He says he's going to buy something in the shop. There's a camera. Character recognition. Everything has been inputted there that when the moment the person takes this thing, comes back again, looks back, takes the camera, looks back, takes the camera, looks back. 3 times character recognition. This person, Obeya, character recognition. You can use that speech recognition. Okay? You are talking to somebody. I had a friend in the UK. He was talking to his girlfriend in America, and he was using terms. They were just discussing things about Al Qaeda and ISIS and things like that. And then they picked him. When the guy now wanted to visit the girlfriend, they denied him a visa. For 10 years, they denied the guy. Okay? Because the kind of language, the speech that he was using has been flagged by the Whitelist agency. Anyway, so all of these things are very important. You can use machine learning approaches. Medical diagnosis, very huge. From symptoms to illness, you can detect it. Web advertisement, you can predict if a user clicks on an advert. I can predict using a model whether this person is going to click on this advert or he will not click on this advert. I'm telling you, YouTube, Facebook, they use that a lot. You see that thing they pass through. They pass through. You say, oh, I'm clicking small, they'll bring you more of that. And these days that people are using liposuction. And they're doing backlinks and front, they're doing backlinks and standard. Backlinks and standard. If they see that you like too much backlinks and standard, they'll bring you more backlinks and standard. And then you start saying that, why am I getting this? You are getting this because you have been recognized. You have been classified. You have been classified. You have been predicted. So that's it. Now let's look at some faces here. Okay? So you can have this as the training examples of a person. And you can have this as test examples. Okay? If you check this, you can use some. In fact, this is used a lot in the military, in the police department, in the CID department, in the criminal investigation department. Is used a lot. Okay? When you're looking for a bad person, you can scan that person, and then the thing will be able to catch. Because there's so many faces, you just need to know who is that person. And based on some characteristics, sometimes you can even tell somebody to draw. You have a specialist in the police department who will say that the man covered my face. I didn't know the man. But if I just touch his face looks hairy, it looks roundish. Then there's somebody drawing. Then they will now put that into the facial recognition system. And then they will run through multiple simulated anomalies and then to be able to detect clearly. There is an algorithm for that can be used for this purpose. And this can classify, because some people have been classified as most wanted, second most wanted, third most wanted. Okay? None of that. There's a movie I used to watch that was very smart on some of this. The next one is regression. As for regression, I'll not even talk about it. We'll look at it deep. Regression is so beautiful, it's so good, it's so wonderful. Regression is used for 2 things. Please take note. 1, to establish causality. 2, for prediction. That's regression. So you use regression to draw causal relationship. That's the first one. You draw causal relationship. You want to establish causal relationship. Whether there is a causal relation, not just a relationship, not just a correlation, but a causal correlation, a correlated relationship. You can use regression for that. Regression models will learn from the label data. Remember, it's a supervised machine learning. Like prices, temperature, sales, it will make them very essential for predictive analysis, regression. They are very, very important. Unlike classification, we've said this before, okay, where you have categories, classifiers, categories. Okay. Regression will give you quantifiable predictions. And sometimes it will give you p-values, statistics, confidence intervals, so that you know that your result you had is reliable. So that is regression. But there's something here which I call kinematics of a robot arm. It's a very, very powerful thing that you can use regression also for. You will learn about this. Or probably not. You'll not even learn about it. Kinematics. This is in robotics, for those of you who don't know. Okay. It has to do with the study of the motion of a robot. Who has seen iRobot movie before? Who has seen iRobot? Yeah, Papa. Papa. Stop watching Cantata. And be watching that Indian movie. Stop those things. I beg you. Watch smart movies. In fact, go and watch the movie called Exam before you write my exam. Go and write the movie called Exam before you write my exam. And watch smart movies, like Inception, like Lucy, like iRobot. Okay. So this is a robot arm. Okay. Sometimes we call it a manipulator. Okay. So you study the motion of the robot arm without considering the forces or the torques that cause it. You're just studying. So kinematics actually focuses on the geometric relationship between the joints and the links of the arm. The links of the arm and then that of the joint. Why is it doing that? It's doing that to determine positions, it's determining velocities, it's determining orientations. Kinematics. That's what it does. Anyway, you're not going to do that. But for those that are actually doing robotic engineering, this is an interesting thing. All of these are supervised machine learning. Supervised machine learning, supervised machine learning, supervised machine learning, supervised machine learning. Now let's look at unsupervised. Unsupervised. Unsupervised machine learning, as you have seen multiple times through here, is a type of machine learning that draws inferences from the data set. The data set has only input. Watch the word, input, no output. Unlike the regression, you have the input and what? Output. But with supervised, it's all input. You are supposed to tell us the connections. There are no labels. And so your goal is to discover the hidden patterns, the structures, the relationships, the connections, the correlations, without explicit guidance on what to look for. You see, you don't know what you're looking for. Clearly, well, you know a bit of what you're looking for, but you don't have a clear guidance on what you're looking for. And so you want something, then that will trigger what you're looking for. You know, sometimes you want to remember something. Hey, there's this guy who acted this movie. Then you are doing, this guy, he has some, a lot of macho, this guy. Then you mention Jason Statham. No, not that guy. Oh, this guy. What you're doing, you're looking for pattern. You're looking for pattern. That's what you're looking for. That's what you're looking for. Then the person will mention Arnold Schwarzenegger. No. Hey, the guy has even acted a movie with Arnold Schwarzenegger. Oh, hey. Then it must be Sylvester Stallone. That's what we normally say. You see, at that stage, the pattern has been recognized. Okay, so you don't really know what you're looking for, but you're looking for patterns. You're looking for patterns, but without explicit guidance. But it's an implicit guidance there. Okay. So the key point about unsupervised learning is that you have unlabeled data. There's a lot of data that is unlabeled. So much data that is unlabeled, and you've got to find out them. Now, when we say unlabeled data, you don't know what the target is. I said it before, the output. You don't know the target variable. Okay? And so that's why we have the unlabeled content there. We don't know the outcome. You have only supplied the input data. So there is no dependent variable. And therefore, you can't say there is an independent variable. You can't say there are features because there are no targets. So how do you talk about features? So we simply call them input data. Okay? And what is doing now is mimicking human intuition. You see the way they were, oh, the guy with the biceps and all of that. They mimicking human intuition to find clusters, to find anomalies, to find certain things that certain things have in common in uncharted data sets. And that is what unsupervised learning is. What are the steps? Because this is what we are going to do, I want to show you the steps. The steps is that first you must have the data. Remember, this is input data. You select the features. Okay? You process the data. You cluster the data using clustering algorithm. Okay? There are several algorithms. So you can see that this group will be here, this group will be there, this group will be there. You validate the result. And then you now have a final, oh, you get to know that it's not that all of them are black, but some of them are gray, some of them are light gray, and some are even very, very white. Okay, now you have a clear grouping in there. And now you bring your intuition and come and interpret the result. I'll show you practical examples of this as we go. Where do we apply this? Clustering is a technique. We shall look at all different aspects of it. Dimensionality reduction, that is another one. Okay, and then association rules mining. These are the things. Now, under clustering alone, there are several methods under clustering. I told you there are quite a number, and look at just 4. Okay. K means clustering is one. Hierarchical clustering, agglomerative clustering are also there. Coherent network, all of these are different methods of clustering. Today is just to let you know what you're going to have. So look at the unsupervised learning technique. Do you see the input data? Look at it. They are all manya. Do you see they are green there? And they are red there. They are green there. They are red there. But do you also see they are blue there? Do you see the blue? It's manya. So we can't find out. And now, let's find it. You know when you have boys and girls mixed together, and you say, all boys, go left. All girls. Now that's because you know boys are there. You get a point? You know boys are there. That's why you say all boys. You know girls are there. That's why you say all girls. Sometimes you don't even know whether they are boys or girls there. So you tell them, go where you're comfortable with. And as they go, you now give a name to them. We will do that when we come to cluster analysis, factor analysis, or principal component analysis. You do that there. So the first thing is that you don't have an output. Okay? There's no training data set. We know that for sure. So you apply an unsupervised machine learning algorithm here. And that will process the data, will analyze the data, and eventually we now have what? An output. And the output, look, the output you're looking for is just the groupings. Once you have the grouping, you clap. And you know clearly that what you're looking for. We are not going to look for numerical, it's just the groupings. Now let's look at an example here. So if you look at this data here, you see I've removed the target. You see that? The first one, there was a target at the far right, but now there's no target at the far right. Everything is manya here. Now make sense of this. That's what unsupervised will do. Make sense of this. Make sense for us. Make sense for us. Okay. To do that, you will use something called association rule mining. Classroom, how many minutes do we have?
We have 5, please. It's to 9:55.
Okay, very good. So association rule mining. Okay, association rule mining is where you can actually pick on something and you know something that must go with it. For example, guys, let me ask you, if somebody buys iPhone, what else does he buy in addition?
Airport.
Sorry?
Airport.
Keys, screen.
Okay, screen protector.
Good. So those things are called association. They have an association. Okay. They have an association. Now, if you check here, which of these things on the number 1, 2, 3, 4, 5, which one is highly associated? Which one has got high association? Is it 1? Is it 2? Is it 3? Is it 4? Is it 5? It's only 1, by the way. Caroline. Afum. Which one has got high association? Pascal.
Sorry, sir.
Pascal.
The 5.
No. Ebenezer. Hey, why have you guys raised your hand and you're not talking? Adote. William.
Say 1.
It's 1. It's 1.
Say please 1.
Yo, it's 1. Unsupervised learning, you use it for customer segmentation, image compression, bioinformatics. You use it for all of that. Brenda, your hand is up. And then the
No, I
other
was
one.
answering 1 as well.
Okay. The other one is classroom. Classroom. We shall look at classroom, as we go. But this is a typical example of classroom. I gave you an example earlier. You can see the blues have been put together, the greens have been put together, and the reds have been put together. There is a system of doing this, guys. Take note. If you look at these 2 people, they are all slim people. But if you look at those people, they are all big people. If you look at these people, they are all pot belly people. So you can see clearly what is happening there. At first, they were scattered. The essence is to group them and make sense of each one. Finally, similarity. We shall do this next week. So I want to just mention, please go and do this as a homework. Go and find out the relationship between similarity and distance. Go and find out. The relationship between similarity and distance. Write it down. Clear relationship between similarity and distance. Then we shall come, because we are looking at similarity properly. By the way, just to give you an idea of similarity, 2 things are similar. Okay, when the distance between them is shorter. Write it down. 2 things are similar when the distance between them is shorter. Now, when the distance between them is a dot, the 2 things are what? Who can tell me? When the distance between them is a dot, then the 2 things are what? Grace.
You can say they are the same.
They are the same.
They are
Perfect.
almost the same.
They are the same. They are the same. They are the same. They are complete replica of each other. Use that and go and learn about this similarity before we meet next week, because there's a bit of calculations there, so you can appreciate it. Finally, reinforcement learning. Okay? Reinforcement learning. Okay? We will not do this, but it's also a machine learning. It's not supervised. It's not unsupervised. Okay? But it is a reinforcement learning. It's also a machine learning algorithm. Okay? It focuses on finding techniques that will enable an agent learn how to make multiple decisions sequentially in an environment with the intention of maximizing the cumulative reward. Okay. So you have an agent. This is a cat agent, and then you are look at the cat. The cat is sitting down, okay. But because the cat knows that there is a reward of fish that he will get, he is supposed to what? Take an action. And the action he has to take is to walk. But when he does the walk, there is a reward that will be taken. And that reinforcement will make it. Anytime he knows that there is a fish, it will reinforce the action. And then it will continue like that. Reinforcement learning is used a lot in practical areas. So in conclusion, look at this table. This table will tell you all you got to know about the supervised and unsupervised learning. Just get 5 major differences between the 2. Find 5 major. That's the whole thing here. 5 areas they can be applied. Okay. Find 5 major differences between supervised and unsupervised. Benjamin, that brings us to the end of the entire caboodle. What again?